Hello friends, in this session we are going to discuss about the angles of a polygon along with the regular polygons. In the previous video we discussed about polygons. See, we have a polygon is a plane figure bounded with n lines, okay, and that polygon will consist of n, it is bounded with n line segments, so along with it forms n angles. Now we are going to concentrate on these angles. Correct? See, we discussed about the sum of the angles of a triangle as 180 degrees. And then from there we are going to find the sum of the angles of a polygon. See, this triangle is a plane figure bounded with three line segments is a triangle. Whereas coming to a quadrilateral is a shape which is bounded with four line segments. We call it as a quadrilateral. And the shape which is bounded with five line segments is usually called as a pentagon. Triangle, quadrilateral and pentagon. Similarly, if we frame a plane figure bounded with six line segments, we will make an example. 1, 2, 3, 4, 5, right? I am going to frame a 6 like this. 1, 2, 3, 4, 5, 6. So a polygon which is formed with three line segments is a triangle, with four is a quadrilateral, with five it is a pentagon, with six hexagon, with seven heptagon, and then octagon, nanogon, and then decagon. So we have different polygons with different number of line segments, right? See, if you observe all these polygons, I am going to frame disjoint triangles in the polygons. See, if you look here, in this polygon of three sides, there involves only one triangle. Whereas coming to this case of polygon with four sides, if I draw this line, usually we call it as diagonal, it divides the quadrilateral into two triangles, and these two triangles won't have any common area. See, the triangles which won't have a common area are called disjoint triangles. Coming to the polygon of five sides, if I join, this is one triangle of this pentagon, and if I join a line like this is another triangle. And if you observe, this first triangle as well as the second triangle have this common area. So we don't call these as disjoint triangles. So don't read this. Divide the whole region or area of this pentagon into different disjoint triangles. So to divide, to make such a disjoint triangles, we need to draw, say, diagonals are the lines joining the vertices starting from one vertex. If you fix this vertex and join this vertex to the remaining vertices of the polygon, so this is one line segment as well as this is another line segment. So now if you observe, this total pentagon area is divided into three disjoint triangles. In the same manner, coming to the case of hexagon, starting with one vertex, I will draw different line segment. This is one line segment, this is another line segment, this is another line segment. So I have four disjoint triangles for an hexagon. Now, if you generalize it, for a triangle, the number of disjoint triangles is 1. For a quadrilateral, number of disjoint triangles is 2. And for a pentagon, the number of disjoint triangles is 3. For a hexagon, the number of disjoint triangles is 4. Like this, if you generalize, for a polygon of n angles as well as if it has n vertices, okay, then the number of disjoint triangles involved in it has n minus 2. It has n minus 2 disjoint triangles. Based on these number of disjoint triangles, I am going to calculate the sum of the angles of that particular polygon. Coming to the case of quadrilateral, see, sum of the angles of a quadrilateral is nothing but calculating the angles at just a minute. I'm searching for one. Okay. See, this is one angle of the quadrilateral. This is another angle of the quadrilateral. This is one more angle and this is one more angle. So to calculate the sum of these four angles in a quadrilateral, what I am going to do? Just I will divide it into two disjoint triangles. Now, if you add these three angles, see, I am indicating this is one angle, this is another angle, this is another angle. In this triangle, sum of these three angles is 180. Whereas coming to the second triangle, in this triangle also, sum of these three angles is 180. See, sum of these three angles is 180 in the upper triangle. Sum of three angles is 180 in the lower triangle. And on the whole, if you observe, see, sum of these two is one angle, Sum of these two is this angle and these two. So sum of the four angles of this quadrilateral is nothing but sum of the angles in upper triangle as well as sum of the angles in lower triangle. Since it has two disjoint triangles, sum of the angles in those two disjoint triangles will make the sum of the angles of quadrilateral, and which is nothing but 2 times of 180 degrees. Two triangles and in each triangle 180 degrees. Whereas if you come into the case of pentagon, the same work will continue. Since it has three triangles, sum of the angles of the pentagon is nothing but sum of the angles of the triangles in three disjoint triangles. See, there are 5 angles in this pentagon. This is one angle and another angle, a third angle, and then one more angle and one more angle. These are the 5 angles. See, to calculate the sum of all these angles, see, I just divided these angles into different parts. This is angle 1, this is angle 2, this is angle 3, angle 4, angle 5, angle 6, and this part is angle 7, angle 8, angle 9. By drawing these two lines, I divided the usual 5 angles into 9 angles. See, from this triangle, 1 plus 2 plus 9 is 180. From this triangle, 3 plus 8 plus 7 is 180. From this triangle, 4 plus 5 plus 6 is 180. And totally, sum of the angles of this pentagon is nothing but, okay, this angle plus this angle plus this angle plus this angle as well as this angle. So sum of the 5 angles of the pentagon is nothing but sum of all these angles, and which is again directly equal to the sum of angles of a triangle for 3 times, and that summation is given as 3 times of 180 degrees. It has 3 disjoint triangles, and in each disjoint triangle sum is 180. So for any polygon having n line segments or n vertices, we are able to divide it into n minus 2 disjoint triangles, and sum of the angles of that polygon is nothing but sum of the angles in these n minus 2 disjoint triangles. So finally, sum of the angles of a polygon is nothing but n minus 2 times the